Today I'm going to solve exam style questions of chapter number 1 of your book. In question number 1 part A, you have been asked to define sampling resolution. This definition is given on page number 40 of your book, and I have copied this definition from there. Let me show you the definition of sampling resolution over here. In part B, you have been asked, describe how sampling resolution will affect how accurate the stored digitized sound will be. The answer is given on page number 30 of your book, that if the number of possible values are increased to represent the sound amplitude, and then the accuracy of sample sound will increase. If only 4 bits will be used to represent one sample, then the file size will be smaller, because only half byte is being used to represent one sample. But if 8 bits or 1 byte will be used to represent one sample, then the sound will be very accurate, because over here the accuracy will increase in the readings, because you will be able to tell the middle point of 9 and 10. Also over here you will be able to tell the middle point of these two, 9 and 10, over here. So it means that the accuracy will become more if you use more bits to represent one sound sample. And so I have taken the answer from here till here, and I have copied it over here, so you can refer to your book also. In question number B part 1, you have been asked to define image resolution. Image resolution's definition is given on page number 40 of your book. So this is the definition of image resolution. Then in part B of question number 1, part 2, you have been told that the color depth of one image is 16 color. So you have to tell the that how many bits will be used to represent one pixel. To find this, we will write the powers of 2 in first row, then we will resolve the powers of 2 in the second row, and we will give maximum value to each place. So to find out the maximum number of bits used, which will be used to represent one pixel. So when we will add up 8 plus 4 plus 2 plus 1, we will get 15. We will add 8, 4, 2 and 1, which will tell us that half byte will be used to half byte is used to represent 16 colors, and 1 byte has 8 bits, so half byte has 4 bits. This is our actual answer, that 4 bits will be used to represent 16 colors. Now in question number B part 3, you have been given the pixels of width and height. In order to find the resolution, we multiply the pixels of width and height to get the number of pixels of one whole image. Then you have been told that 256 colors can be used to represent the image. In order to find the number of bits that can be used to represent 256 colors, we will again write the powers of 2 like this, and when we will add up these powers, we will get the value of 255. It means that the range of 0 to 55 colors requires one whole byte, because we have given maximum values of each place over here, and then we have got 1 byte. 1 byte has 8 bits. It means that the color depth of this given image is 1 byte. So we will multiply this number of pixels with its color depth, which is 8 bits. Color depth is represented in bits. The answer will we will get the answer in bits, but bits is not enough, because we are supposed to convert bits to bytes by dividing by 8. As 1 byte has 8 bits, so you will divide this value of bits by 8 to get the value in bytes. Now that we have got the answer in bytes, now we are going to convert it into gigabytes, because the requirement of our question is to convert the file to gigabytes. Again, we will refer to page number 32 of the table given on page number 32 of your book, because that table will not be given in your exams and you need to learn that table by heart. You have been given the value of 1 gigabyte as 1073741824. So you will divide bytes with 1073741824 to get the answer in gigabytes. So actually we have calculated the resolution. So actually we have calculated the resolution first of all. Then we have calculated the number of then we have calculated the color depth. After that we calculated the size of file in bits. Then we converted it into we converted it into bytes by dividing it by 8. Then we converted it into gigabytes by dividing it by 1073741824. In part 4 of question number 1, you have been asked to tell a file compression technique that the developer can use to reduce the size of an image. You know that there are two types of compression, lossless and lossy, but over here the better option will be lossy compression, because in lossy compression unwanted pixels will be deleted and the file size will reduce to a greater extent as compared to the lossless compression. And when the file size will become very less, then the uploading and downloading of file will also take lesser time. So lossy, because the question is of 3 marks, so we have to give 3 points to in order to justify our answer also.